Good morning. It's a pleasure to be here with you today. I apologize I wasn't able to attend personally, but I did want to take this opportunity on behalf of the CPV Consortium to share with you the status of the CPV industry and the advantages and the opportunities that are quickly unfolding for this technology in becoming a major source for renewable energy across the world. CPV is a young technology compared to many of the others. However, it has grown at a very, very rapid pace and made tremendous progress in the last several years. 3 years ago, you would have found a handful of companies doing CPV systems, and all of those still in the lab. Today, you find over 36 companies doing CPV systems. You find over a dozen companies dealing with cell technologies and the advancements that can be made there, and you find a complete infrastructure of support industries from materials to processes to deployments and installations. So a very strong infrastructure has been pulled together very quickly, positioning CPV now to be on the cusp of delivering megawatts of electricity and gigawatts in the very near future. Now, what I'd like to do for you today is first take you through a little informative piece on the technology itself and what really makes CPV different from the other solar technologies.
Efficiently capturing, converting, and delivering solar energy is the challenge that faces the world in using the sun to meet increasing energy demands. There are many technologies, silicon PV, thin film, CSP, and CPV, all with an important role in meeting the demand for clean, renewable energy. Concentrator photovoltaics, CPV, is the newest and most innovative technology to enter the commercial solar market. High-volume manufacturing of CPV technology is now a reality, making it a viable and cost-effective solution for global deployments. Concentrator PV systems convert sunlight directly to electricity, just as other photovoltaic technologies do, however, with some important differences. First, CPV systems use different PV cell technology. CPV systems utilize high-efficiency, multi-junction cells, not silicon. These cells provide over twice the conversion efficiencies of most silicon cells, approaching 40+%. The result, the use of a fraction of the amount of photovoltaic material used in traditional PV systems. Second, CPV systems use optical elements, mirrors, or lenses to collect and focus sunlight onto these high-efficiency cells. Similar to a telescope, the CPV optics are trained on the sun's position and collect and concentrate light hundreds of times onto the solar cell. Third, CPV systems incorporate precision, dual-axis tracking to keep the concentrators in alignment with the sun throughout the day. By tracking the sun from sunrise to sunset, CPV systems produce energy at a steady rate throughout the day, and power production remains at high levels during afternoon's peak demand hours. By replacing expensive PV material with comparatively inexpensive optics, utilizing high-efficiency PV cells, and tracking the sun, energy generation potential is much higher and cost of energy much lower than with other solar technologies in the high solar resource regions of the world.
Well, with that description of the CPV technology and how it differs from traditional solar technology, let me share with you some of the ways that really impacts energy production. CPV technology uses direct sunlight, and as a result of that is really focused on the high solar resource regions of the world. If you look at a map of the world, you would find about a third of the land surface to be in areas where the solar resource is ideal for CPV technology. And very importantly, that's not areas that are in the middle of nowhere where power isn't required, that represents about 40% of the world's population. So you've got a new technology that's disruptive in its design, and it's able to meet the needs of a third of the world's surface and 40% of the world's population. So you've got a large market opportunity for the technology. Now, one of the key things when you get into these high solar resources, which is quite often desert land, Mediterranean regions, that type of area, you also tend to find high temperatures. Well, one of the advantages CPV has is that it does not suffer from temp degradation as do traditional photovoltaics such as silicon and thin films. Now, this matters a lot because if you were to take, for example, a 205 watt PV panel and a 205 watt CPV panel, and you put those in a climate at 40 degrees C, which is very typical of these high solar resource regions, you would all of a sudden have only production on a PV panel of about 150 watts of electricity, not its rated 205 watts. Now that is a dramatic hit to energy production from photovoltaics, and one of the reasons that silicon-based PV isn't always as ideally suited for those regions as it is other regions of the world. On the other hand, CPV technology, which uses these high-efficiency 3-5 cells, which are very capable of handling the heat, it will generate almost its full rated power of 205 watts. You would lose less than 5% of the power rating even at 40 degrees C. So this becomes a very critical element in the cost structure for energy generation, because the more energy you generate, the lower your cost in cents per kilowatt hour will be for that energy generated. So again, you're looking at very high solar resource areas where you have high temperatures, and CPV is well suited to that environment. Another really important advantage of CPV technology is its scalability. Now, scalability can mean really two different things. First, let's look at scalability in terms of the technology itself. If we look at the desire to have 15% of the world's energy sourced from solar by 2020 or 2025, there's a tremendous amount of actually raw material that would be required to do that with existing technologies. CPV, however, because it's largely created out of glass, aluminum, plastic, depending on the various types of systems, and uses very little photovoltaic material, you can scale to gigawatts of electricity very rapidly from a material standpoint. On top of that, the amount of capital it takes to produce CPV systems is dramatically lower than it is for other technologies. So your CapEx investment to move to very large manufacturing capabilities and the time required to build very large manufacturing resources is dramatically less than it would be with other technologies. So you can take the demand and you can create the supply fast with much lower capital investments than would have otherwise been required. Now, the second part of scalability that I believe is very important is actually in the plant deployments themselves. A lot of technology needs to be a 50, 100 megawatt facility to really reach cost effectiveness. Other technologies prefer, small rooftop applications. CPV is very flexible in how it scales. So you could put anything in from a few hundred kilowatts to offset peak demand at an industrial plant, to putting in a 5 megawatt power plant for distributed generation, or a 100 megawatt utility scale plant as a major power field. And you can scale those up in segments, and you can maintain those in individual increments, so you don't have to take large power facilities offline for maintenance. So the flexibility and the scalability of CPV is a very, very strong advantage as we start looking at large and big solar opportunities. So as you do deploy these projects, whether they are small projects or utility scale projects, one of the key things is CPV will give you more energy output per area of land. So in places where your land costs are very high, or where there are land availability constraints, you're going to be able to generate a much larger amount of energy out of that area of land than you could with other technologies. The power density, the energy density is really optimized with CPV. The last area I'd like to talk a little bit about is the environment. Producing clean, renewable energy is very important, and doing it without wasting or contaminating our natural resources is very important. CPV is a waterless technology. In generating electricity, we do not use any water. If we compare that to other technologies, nuclear, steam plants, even CSP, the water consumption can be as great as 850 to 1,000 gallons per megawatt hour produced. In the high solar resource regions of the world where water is a scarcity, this can be a real issue in terms of scalability and ongoing production of the technology. Also very important is that the manufacturing of the technology is environmentally sound. CPV has an energy payback of less than a year, anywhere from 6 months to a year. Other PV and other technologies are as much as 2 to 3 years. So you have very quick energy payback, and typically you're going to find CPV systems to be highly recyclable. In some cases, for example, our Soul Focus system, we're over 95% recyclable, and you're going to find much higher degree of recyclability in CPV than other technologies. So with that, I think it would be important now to, you've seen how the technology works. I've shared with you what I believe it really does for the industry and for energy production. Now I'd like you to see it in action. We're going to take a little virtual trip to ISFOC, which is a 3 megawatt power plant, which is being implemented, and part of it is already on a grid. And this facility is the first to put multiple CPV technologies on one site and really strive to advance the technology as a mainstream energy source.
We are helping the industry to move forward and get the CPV power plants and CPV technology put into place at an industrial scale through the deployment of 3 megawatt power plants of different technologies. So all these power plants and all our infrastructure will be devoted to the industrial level, helping and collaborating with the companies, and also academic level.
So the ISFOC program in Puertollano will be the first in the world with different technologies in the same location. So we will study different technologies with the same weather and the same conditions. The cells are going to be very cheap, and all the other elements are really cheap now, because lens, glass, and metal, plastic is very cheap because it's the actual industry. So I hope that in 1 or 2 years the CPV will be really cheaper than the PV.
CPV in the market is starting. PV and other renewables have been in the market for a number of years now. They are already at the end of the learning curve, and I believe that the learning curve for CPV could be much shorter, and in a very short term we can show the advantages of this technology and how they can be implemented in the general energy supply. CPV is the most promising energy resource for the future.
On behalf of the CPV Consortium, I'd like to thank you very much for this opportunity to speak with you today. The industry is moving rapidly. It's made tremendous progress, and it has tremendous headroom for more progress as we move to megawatts of installed capability in the upcoming years. If you have any questions, I'd invite you to contact the CPV Consortium at our website, and we can put you in touch with people or provide answers to your questions. Thank you again. It's been my pleasure.